Hi children. Last week we have discussed the relation and functions. In this, first topic is relation, second topic is function. Okay, so you know what is a relation. This already you studied in last year. It is a subset of Cartesian product, and where R is a subset of xy, element of x by y. That is the Cartesian product, such that x in relation y. Then how many relations are there? Number of relation will be 2 raised to pq, where p is the number of elements of A, q is the number of elements of P. Then empty relation, universal relation, that you know what is empty relation, children? No element of x is related to any element of x. Universal relation means every element is of x is related to every element of x. Then it's the important one. Okay, reflexive, symmetric, transitive. Children, reflexive means a relation R defined on a set A is said to be reflexive if X is an element of R for every element of X belongs to R. Then symmetric means if xy is an element of R implies yx is an element of R. Transitive means if xy is an element of R, yz is an element of R, then xz is an element of R. If the relation is reflexive, symmetric, and transitive, we can say that it is an equivalence relation. Now, equivalence class. We have an equivalence relation. We are dividing into x into mutually disjoint subset called partition. These 3 points are very important, children. All elements of AI are related to each other. No element of AI is related to any element of AJ. And AI union AJ is X, that is our set. AI intersection AJ equal to 0. The subset AI and AJ are called equivalence class. Now, here determine whether each of the following relation are reflexive, symmetric, and transitive. Here I will do a relation. Here I will do relation R in the set A is 1, 2, 3 to 13, 14. R is xy such that 3x minus y equal to 0. So R you will get like this, na? 1, 3, 2, 6, 3, 9, 4, 12. Reflexive means I will take one element. So let 1 is an element of A, but 1 should come. But is 1 here? No. That means it is not reflexive. Then I will take 1, 3. If I am taking 1, 3, 3, 1 should be there. But 3, 1 is not there. So it is not symmetric. Then transitive. That means 1, 3 is there. Then ending this 3. That is 3, 9 is there. But 1, 9 is not there. So it is not transitive. Here the relation in the set n of natural number x, y such that y equal to x plus 5 and x less than 4. So I got the elements. That reflexive means if I am taking 1, 1 should be there, but 1 is not there. Symmetric. When I am taking 1, 6, 6 should be there, but 6 is not there. Then transitive means when I am taking 1, 6, here we have no case. Look, children, 1, 6. Anyone starting with the 6? No. 2, 7. Anyone starting with the 7? No. 3, 8. Anyone starting with the 8? No. So here we have no cases to explain the transitive. In that condition, we will write it is a transitive function relation. Then here This is very important. Show that the relation R in the set R, that is a real number, okay? R is relation is A comma B such that A less than or equal to B square is neither reflexive nor symmetric nor transitive. A less than or equal to B square. That is, I will take this is real number now, so I can take 1 by 2. When I take 1 by 2, any children 1 by 2 is equal to 1 by 4. No, it is less than or equal to 1 by 4. So, is it true? No, because 1 by 4 is 1 by 4 is smaller, right? So, it is not reflexive. Then I will take 1, 2 is an element of R. That means 1 is less than or equal to 2 square. That is correct. But 2 is less than or equal to 1 square. That is not correct, right? That means 2, 1 is not an element of R. So it is not symmetric. Then is transitive. So I will take the example. Let 5, 4, 2 is an element of R. So 5, 4. That is 5 less than or equal to 4 square. 4, 2. 4 less than or equal to 2 square. But 5 less than or equal to 2 square, children? No. So it is not transitive. Now here, A less than or equal to B cube is reflexive, symmetric, nor transitive. So reflexive. So I will take example. Let 1 by 2 is an element of R. So 1 by 2, 1 by 2 is an element of R. This R is the relation. This R is the real number. 1 by 2 is less than or equal to 1 by 8. Is it correct? No. 1 by 8 is the smaller one. So this is not reflexive. Symmetric. 1 by 2 is an element of R. 1 is less than or equal to 2 cube. But 2 is not less than or equal to 1 cube, right, children? So 2, 1 is not an element of R. So it is not symmetric. Transitive, you can take any example, okay? So it should satisfy the condition. That's why. So 9, 4, 2. 9, 4 is an element of R. 9 is less than or equal to 16. 4, sorry, not 16, 4 cube. 4, 2 is an element of R, mean 4 less than or equal to 2 cube. But 9 is not less than or equal to 2 cube. So it is false, so it is not transitive. Now, this question. Show that the relation A minus B is even is an equivalence relation. Then all elements of 1, 3, 5 are related to each other and all elements of 2, 4 are related to each other. But no element of 1, 3, 5 is related to any element of 2, 4. This is our condition, na? Equivalence class condition. Now reflexive. Let A is an element of A. A comma A is an element of R. I can substitute here modulus of A minus A. So you will get 0. 0 is an even. So R is reflexive. Symmetric means what? Let A comma B is an element of A. Let A comma B is an element of R. Modulus of A minus B is even. Modulus of B minus A, I can write it as minus of A minus B, right, children? That means this A minus, here magnitude only, modulus function, so positive only will come. So it is even. So B comma A is an element of R. That is symmetric. Transitive means modulus A comma B element of R, B comma C element of R. So modulus of A minus B is even, modulus of B minus C is even. So you can write it as modulus of A minus B, you can write it as plus or minus, A minus B, you can write it as plus or minus 2p, na? B minus, because this is a even function, that means it is multiplied with the 2. Then you add this 1 and 2, you will get A minus C is plus or minus 2 into P plus Q. So that is also even. So you can say that AC is an element of R, so it is transitive. Since R is reflexive, symmetric and a transitive, so R is an equivalence relation. Now you have to find the element that related to 1, 3, 5. So modulus of A minus B you can do, that is 1 minus 1, 1 minus 3, 1 minus 5, 3 minus 1. Any case your answer will be even. 2, 4. This is also 2 minus 4, 4 minus 2, 2 minus 2, 4 minus 4. That is also even. So here the elements are related to each other. But when you take 1, 3, 5 and 2, 4, 1 minus 2, it is odd. 3 minus 2, it is odd. That understood? So this is the equivalence class. Now, this is also same way you can do. Now give an example of relation which is symmetric but neither reflexive nor transitive. That you can take any example, children. You can take numbers, you can take conditions. We already did so many problems. Okay. Now go through that. Here one, two. Here I take an A, then A by A I am writing. R is 1, 2, 2, 1. So 1, 1 is not here. So it is not reflexive. But 1, 2 is there, 2, 1 is there. So it is symmetric. But 1, 2, 2, 1 is there, but 1, 1 is not there means it is not transitive. Similarly, you can do for these examples. Okay. Now, this all we can do with the same process. Okay, here also here, this all are easy, but here only look set of all element in A related to right angle triangle T with the side 3, 4, 5. Here the condition is same number of side. So if it is right triangle also, we have only three same number of side mean 3 side. That is the triangle. So it is the set of all triangles. This formula you have to study, children. Reflexive relation 2 raised to n into n minus 1 or n square minus n. Symmetry relation 2 raised to n into n plus 1 by 2. N into n plus 1 by 2. Then this you know already. Total number of relation is 2 raised to mn. If only one a relation on set A will be 2 raised to m square. Here also, equivalence relation we can easily prove. When y is equal to 2x plus 4 mean what will be the parallel line means only the constant will change the, so it will be 2x plus c, where c is a constant. Okay, children. So I hope the relation is clear. Okay, just go through the questions. Okay, if any question that I didn't discuss in this video, you can ask me. And any doubt in the any doubt in this section, please ask me. Okay, children. Thank you.